At the core of the PSA plant are two sieve beds. Here, oxygen is separated from compressed air using the pressure swing adsorption cycle. Let's look at a schematic view of the sieve bed so we can better understand exactly how the pressure swing adsorption cycle works. Each sieve bed consists of a pressure vessel filled with small round grains of a special man-made material known as zeolite. When compressed air flows through the zeolite, nitrogen molecules in the air will stick to the surface of the zeolite. This process is known as adsorption. Let's look at just one sieve bed to see how this adsorption separates oxygen from air. Air from the inlet passes through the feed valve, entering the bottom of the sieve bed. As air flows through the zeolite, the nitrogen molecules stick to the surface of the zeolite, while oxygen and other trace gases pass through. The zeolite, however, can only trap so much nitrogen, so as more air flows through the sieve bed, the zeolite will start to become saturated with nitrogen. Notice the dark region at the bottom of the sieve bed. The oxygen and other trace gases that pass through the zeolite leave the top of the sieve bed and exit out the upper product line. In a well-functioning PSA plant, the oxygen will be between 90 to 96% pure. This process continues until all the zeolite in the sieve bed is saturated with adsorbed nitrogen. To separate more oxygen, we must first remove the nitrogen that the zeolite has collected. Since the sieve bed is under pressure, we can remove the nitrogen by exhausting the sieve bed to the outside environment. To do this, we close the feed valve on the very bottom rung and open the exhaust valve just above it. High-pressure, nitrogen-rich gas from the sieve bed is now exhausted to the outside. The exhaust passes through a muffler to reduce noise. As pressure drops, more nitrogen will desorb or become unstuck from the zeolite and flow out through the muffler. This will continue until the sieve bed reaches ambient pressure. Now, the sieve bed is ready to separate more oxygen. There are, however, two sieve beds. Both sieve beds go through the same cycle but at opposite times. While the left sieve bed produces oxygen, the right sieve bed exhausts nitrogen. Likewise, while the left sieve bed exhausts nitrogen, the right sieve bed produces oxygen. It is clear now why there are 4 valves on the bottom of the sieve bed. The 2 valves on the bottom rung are the feed valves. They allow compressed air into the bottom of each sieve bed. The 2 valves on the second rung are the exhaust valves. They allow nitrogen in each bed to be exhausted through the muffler. In general, the feed valve on one side and the exhaust valve on the opposite side will open and close at the same time. Let's take a look at the output of the plant. We need a way to keep the oxygen from the active sieve bed from flowing to the opposite sieve bed and being exhausted out the muffler. This is what the 2 valves on the top rung are designed to do. These 2 valves are known as check valves. They only allow gas to flow in one direction. Here, oxygen can only flow from one sieve bed to the output, and not from one sieve bed to the other. The rung below the check valve is known as the purge line. A plate or plug with a small hole, known as an orifice, will allow a small amount of oxygen to flow through the purge line. Notice that the orifice is not a valve and is always open, allowing some amount of pure oxygen to flow between beds. To understand what the purge line does, let's look again at the left sieve bed as it finishes exhausting. At ambient pressure, the sieve bed will have exhausted almost all the nitrogen it collected, but some nitrogen will remain. To achieve high purity, we must remove this nitrogen. A small amount of oxygen from the opposite sieve bed flushes out the remaining nitrogen in the zeolite, purging the bed. Before the end of the cycle, some of the purge oxygen will be exhausted out the muffler. While the purge line does indeed waste some oxygen, it is essential for maximizing the purity of the oxygen. To understand the purpose of the final valve, the equalizing valve, we first need to examine the pressure in each sieve bed near the end of a cycle. Here, we see that the left sieve bed is at or near its maximum pressure, and almost all the zeolite is saturated with nitrogen. We also see that the right sieve bed is at or near ambient pressure. In addition, the zeolite here has been purged with nitrogen. Since there is still some unsaturated zeolite, we could continue to produce some oxygen in the left sieve bed. However, there is a more efficient option. We can instead use some of the compressed oxygen in the left sieve bed to begin pressurizing the right sieve bed. This is known as equalizing the sieve beds. The equalizing valve opens, joining both sieve beds together. Oxygen rushes from the left sieve bed to the right sieve bed until both of their pressures are roughly equal. Pre-pressurizing the empty sieve bed with oxygen helps jumpstart the nitrogen adsorption. Recall that zeolite absorbs nitrogen better at high pressures. Having seen all the parts of the PSA plant, let's review the full pressure swing adsorption cycle. We start just after equalization, with the left sieve bed having been saturated with nitrogen and the right sieve bed ready to produce oxygen. The right feed valve and the left exhaust valve are opened. The left sieve bed begins to exhaust nitrogen, while the right sieve bed produces oxygen. Notice the purge line is flowing, and some oxygen is being exhausted out the muffler. The pressure in the left sieve bed has fallen, while the pressure in the right sieve bed is rising. When the right sieve bed is almost completely saturated, the right feed and left exhaust valves are closed. The equalizing valve is opened, pre-pressurizing the left sieve bed with oxygen. The equalizing valve is closed, while the left feed and right exhaust valves are opened. The right sieve bed begins to exhaust nitrogen, while the left sieve bed produces oxygen. Notice that the purge line is flowing, and some oxygen is being exhausted out the muffler. The pressure in the right sieve bed has fallen, while the pressure in the left sieve bed is rising. When the left sieve bed is almost completely saturated, the left feed and right exhaust valves are closed. Again, we equalize the sieve beds, helping to begin production on the right sieve bed. Through the pressure swing absorption cycle, precious oxygen can be made from compressed air and distributed to patients in need.